Hello everyone, so in this particular video we are going to understand the concept of datasets and data loader in PyTorch. Now you cannot skip this video because in all the programs, almost all of the programs in PyTorch that you will be writing from now on will be requiring the concepts of datasets and data loader. So in any program, any model that you need to train, you will have to use these concepts. So without any further ado, let's get started. So first thing that I need to do is going to import torch. I'm also going to import numpy, so import numpy as np. After that I'm also going to import pandas as pd, and lastly I'm going to import sklearn from sklearn dot datasets. For the dataset, import make classification. So I'm going to run this particular cell. After that, the first thing that you need to do is actually create data, and after that we will be understanding how we are going to use dataset and why it is used and why we are going to use data loader also. So we will say train target, we will say make classification. I have explained this in other videos, so I'm going to go really fast with this. Samples equal to, let's say 5000. We are going to have a lot of them, so let's say features, I mostly keep it to 10. Then you need the informative features 8, and then random state, let's say 1 2 3 4, and also number of classes. Since we are using binary classification, let that be equal to 2. Then we will change the data frame from pandas to from numpy to a pandas data frame. So we will say train, and we will just leave it here. Then we will say train dot head to see what are the values that we have got in this one. So if you can see, there are 10 columns 0 to 9, and then you have basically numbers over here. Okay, so the first thing that we need to understand is dataset. Now for that we'll have to go to the slides. So in PyTorch you actually have to create a class for dataset. What is going to do? It is basically going to help you to take data and structure it into a particular format that will be given to the model. Yes, listen to me one more time. It will structure the data. Your data is basically the data frame that you can see on the right side over here. So if you remember train, that we converted into a data frame, this was the data frame. Okay, this SL, the serial number, I have added just for reference so that we can understand what the data frame was. From C1, here you are seeing C6, the column 6, they were column till 10. Okay, so 0 up to 9, and the target one I have appended again for understanding purposes. So what it is going to do, the data set will take one by one rows. Now it may be one by one, like 1 2 3, or it can be randomly, or it can be defined by you also. We'll see sampler what that is, maybe not in this video but some other video. So we will, what basically this dataset class is going to do, it is going to take one by one rows and then convert it into a format so that PyTorch can easily understand. Okay, so how it is done? So first you need to write a just class and then give a custom name. I mostly used cust.dat. You can also write your own name, doesn't matter, it can be anything. Okay, then you need to write it, it has to be inherited from this dataset class. So torch.utils.data.dataset. Then you need to define three functions. First is obviously the init function, the constructor, where you will be initializing the variables. So if there is df, you need to write self.df equal to df, then next line self.var1 equal to var1, and you can have as many variables you want. The most important functions are these two, that are, you have to mention them. So def underscore len underscore. So this function basically returns the length of the data set. So in this case, what is the length? It is 8. If you remember in the code, we have given number of samples, n samples equal to 5000. So let's say if you are taking the whole data set, then your len function len should be able to return, in this case 8. In our case, if we are using the full data set, 5000. So number of rows, basically this function will return the number of rows that are there in the data set. Now getitem, it will take another input as index, and for every index, let's say for 1, it will return this particular row in a format that you want the model to feed. Because one thing I can say that, okay, this one is in numpy format right now because it is in data frame, so we have to convert it into a tensor So that is one operation. There can be many other operations, but the basic thing that getitem does is it takes each rows, it can be any row from here, and then it modifies it in such a way that the model, PyTorch model can take. So basically, I'll repeat it. This one is for initialization of the class. This one will give you the number of rows in the data frame, and getitem will take each and every row and convert it into a format so that you can feed it into the model. So I hope you understand. Let's go back to the code. Okay, now that we have understood what dataset class is, let's go and implement it. So we'll say class, and I mostly use custdat. You can use anything. Then from there we'll say torch.utils.data.dataset, and then we have to define the three functions. So first is the init function. In this case I will be giving, let's say, train and target, and then we will first have to initialize. So we'll say self.train is train, and then say self.target is equals to target. That's it. The second function, that if you remember, it was len underscore underscore len underscore underscore, and we'll pass self. Now it was supposed to return the number of rows. Obviously it will be self.train dot shape of 0. In this case, if you remember, let me just print it for you. Train dot shape should be 5000 comma 10. So 5000 comma 10, and if you print the 0th index, you should get 5000. So in this case you are basically giving 5000 because there are 5000 rows in this particular data frame. Then we had to give get item, so get item underscore underscore, and then you have to also pass an index. So let's say if the index value is 2, then this particular row, this particular row should be given along with the target variable. So I'll show you how to do it. So let's say you have this, and let's say the dp data point is going to be self.train train.ilog. I hope you understand the ilog function, or if you don't, go to my pandas series and watch it. ilog.values. Okay, so this is going to be our this entire row. Okay, it can be, if 0 is the value of index idx, then this particular row will be given. If you want to see, you can actually see it. Just do return dp, and let's instantiate the class. Let's say train and target. So even if there is an error, we will know, and get item of 0. Okay, so fine, there were no error. So you can see the first one was 2.26, first one is 2.26, then 2.232, 2.232, and you can see all the values will match. Okay, you can see for yourself that all the values are going to match. So which means that yes, the 0th index row we are getting. Now what was the target? Let's say target is equals to self dot target, and I'm going to write idx, so index, and let's return this also. Let's see what. Okay, yeah, so we can see 0 was there, but I haven't printed the target column target list for you. The first one should be 0. Yeah, the first one is 0. So this is what we get. Now I told you have to condition, you have to change the values in such a way so that you can directly give to the model. Obviously a PyTorch model will need tensors and not numpy, because right now we have this is just numpy, we haven't converted it to. So let's say if you do type of train, you will get a numpy array, numpy.nd array. Okay, this is the data frame, but data frame is also, at the end of the day, it's a numpy array. Okay, I forgot that I had already changed it. Yeah, I had changed it. So what we have to do is we have to convert this into a torch.tensor. So if you remember, torch.from numpy, or I think, yeah, let's see if we can do this, because it's and this one also, targ is equals to torch.from numpy, and let's give it targ. If there is an error, we will see. So what we are going to do, we have converted into torch variables, and now we are going to give both of them. that is the data point as well as a target. Remember, you have to give both of them. Some people write it like this, they pass a tuple. If you don't pass a tuple, PyTorch will implicitly make it a tuple. So if there is a flaw, we will come to know. Yes, so there is a flaw. Torch.from numpy. What you can do instead of numpy, I think you can also use tensor. So these are the things that you learn after practice. Okay, so I knew this was going to be an error from before. However, you don't have to make a lot of changes. You basically have to, from numpy, you have to remove the numpy and just convert it into tensor, torch.tensor. So once you can see, now that we have done, we have got the values. So dp, which is our data point, we have got it as first value of the tuple, and the second value of the tuple is the target. So this is what we are going to do. Now remove 0, put 1, you'll get the same thing. Okay, minus 0.64 and minus 1 point minus 0.64 minus 0.13. So basically what I'm trying to say is you are going to get all the values, okay, depending on the index. So now let's, after having understood data set, now let's understand data loader and how to club them together. So let's go back to our slides. So data loader is actually just a function that you use in order to merge all the columns and give one entire let's say a batch. So it is used for making batches. Okay, so what is this? Cust.dat, we have already written the function before, and I have instantiated it and said let's call it cd. So data loader, you have to write torch.utils.data loader. I'm going to implement it in the colab, so you don't have to worry. We are going to use this, and then first parameter that you have to pass is the class, is the instance of the class itself, the object. Okay, the second parameter, and this is a compulsory parameter that you have to pass, is the batch size. You can use it 16 mostly with text one, or like the simple ones I mostly use something in 128 or 256, but if you are using images, obviously you'll have to keep it lower than that. So 16, in this case you can definitely use 128, 256, or maybe 1024 even. However, in images you use 8, 16, like that. You can definitely change it right now. Shuffle equal to true. Now basically what it means is, ideally what will happen is it will take the idx. You remember in the get item idx, the get item of idx in the get item, the first will be 0, then it will be 1, 2, 3 up to, in this case 8, or ideally it should go to number of rows that are there in your data frame. When I say shuffle equal to true, now it does not mean that it will go 0, 1, 2. It can go anywhere. It can go 5, 29, 362, whatever. It can go in any random order. So shuffle definitely just means that you are going to shuffle the order. That's it. Number of workers. So this is going to be basically your parallel processing to fetch the data. Now ideally on colab I do not use more than 2 because I have encountered errors sometimes. That's why I use 2 at the max for colab. Pin memory is basically used when you have let's say GPUs. Right now we are not using it. If you want to know how to use GPUs, go on my channel. There is a video on that. The two functions that I'm not going to explain right now, which are actually important, and we will be making another videos. I may not make it a part of this current series because you need to have a bit of experience for this too. Sampler is somewhat related to shuffle. It is basically how you are going to strategize and index the get item function, and collate function is a little bit more in depth because you have to understand what it does and how things are done in DataLoader. So you just have to focus on the 5 things right now, on most importantly the first and second and the third. That's it. Okay, so let's go back to our code. So now we are going to implement the data loader. Let's call it DL. So before that we actually need to class dataset cd. We actually need to instantiate the class. So let's say cust.dat, and we have to send train and target. Okay, so we have done till here, and now we are ready to write our data loader. So data.utils torch.utils.data loader, capital L. Okay, most of the time we forget capital L, and the first parameter was cd itself. Next was, if you remember, batch size. Batch size, I'm going to keep it 16. You can keep it, it depends on the type of data. For this type of data definitely you can go a lot higher than 16. I'm going to say shuffle equal to true. Now ideally you will not understand, okay, you will be able to understand, but mostly we don't really care about shuffle true or false. It depends on what we are trying to do. We are trying to train, we are trying to validate, we are going to test. It depends on a lot of things, but generally true is a good idea. Num of workers, as I told, mostly when I'm using colab I don't use more than 2. Then the last one was pin memory. Right now we are not using GPU, so we will say equal to false. Okay, so we will just hit enter with this. Okay, shift and enter. So this has run, and to get the results we'll say for data in DL, and then we will say print data. We are just going to print one instance, and then we will say break, so that our console is not cluttered. Okay, so if you see, we have got a list. Okay, so let's print the first element of the list, and this pay close attention because I'm going to explain what actually happened. So you see you have got a tensor. Now what is the shape of this tensor? Let's print the shape of this tensor. So we'll say shape. Now you see 16 comma 10. Why 16? Now again let's print back the data. Okay, the reason is we have gotten 16 is our batch size. So what it did, it gave 16 different values to this getitem function as idx. Now since we have taken shuffle as true, so we don't really know what it gave. If you say shuffle equal to false, then I'll be able to explain it very much more clearly. So if you're given shuffle equal to false, so obviously the first one is 0, 1, 2. So what it did, it took 16 indexes, 0, 1, 2, 3, 4, 5 up to 15. So it took 16 indexes, it gave one by one to this 0, it gave 0, and when it gave 0 you got the 0th column. So 0th column was 2.26, 2.23. So here also you see 2.26, 2.23. So it got the entire row over here. Okay, it got the first row because we have given the first 0 as the IDX. The PyTorch data loader gave 0 as the IDX. Then second time what it did, it gave 1. And after giving all the 15, what it did, it made it into a particular matrix that you can see. So that's why when you put the shape, you got 16 comma 10. So 16 data points, 16 rows and 10 columns. That is what exactly happened. Now here after this, what you could have done is we will say model and in just passed train data of 0. That's it. Now, so we understood what this does is data loader, it just calls the dataset function a couple number of times. How many times? Batch size number of times. Each time batch size number of times, and it gets batch size number of rows for you, and then you manipulate it over here. You can see you get TP, and then you manipulate it. In this case we just converted it from normal numpy to torch by torch tensor, and then what you do, you just get it back over here. Okay, and then shuffle number of workers, not really important right now. And so once you have gotten the data, what you can do is you can say model dot in model in bracket you can say data of 0. So what is data of 1? It is basically your target. So you remember, let's print the target here itself. So you will see this particular, these are 16 numbers will match. Okay, you will see data of 16. Let's say print 16. Okay, so let's say if you are going to print, you'll see these are exactly the same. Okay, these are exactly the same. Why? Because it took from 0 to 15 and these were the targets. Okay, DP and target. So what data loader, I'm going to explain it one more time. What data loader does, it calls the CD function, the custom data function, this many number of times, batch size number of times, depending on whether the shuffle is true or false. If I have kept here false, so that now it will call it 16 times from 0 to 15 in one iteration. Another time what will happen, because we have written break, if we did not write break, it will go back again, and from now first time it was, the first batch was 0 to 15, now from 16 to 31, like that. Okay, so this is what is going to happen. So I hope this was clear. We will be using this from the next video. I think we will be making a simple neural network in the next video. We will be using in all the programs, almost all the programs in the following lectures. So if you didn't understand, you can write it in the comment section if you have a problem, or you can go on my Fiverr page and then we can have a deep down discussion on anything that you haven't understood until now, or any of your projects, or anything related to computer science. If I'm able to help you, you can get my help there. So thank you very much, and bye.